Abby, do you want me to stop sharing my screen? Are you seeing that?
You can just leave it up on there. We'll leave this as the title
Okay,
slide while we're doing the housekeeping. We're going
thanks.
to give it another minute for everyone to join and then we'll get started. But thank you to
Great.
everyone who's joined already. Now's a great chance to grab some water and we'll get started in 1 minute. All right. Well, thank you everyone for being here today. My name is Abby Jager. I'm a program manager here at Solar Oregon. We are a local 501c3 nonprofit that focuses on education and advocacy around solar power. We do a variety of different events throughout the community and online in order to help people go solar and take control of their energy future. Today, we're going to be hearing from Stracker Solar, which is a Oregon founded and local company that is exploring some new solar panel technologies. It's really exciting that they're Oregon locals, and personally, I'm really excited to hear about their new technology. This webinar today is made possible by support from the Energy Trust of Oregon. Energy Trust of Oregon is a government funded nonprofit that focuses or partially government fund or government mandated nonprofit funded through the local utilities that advocates for renewable energy and has a variety of great programs. Thank you, Energy Trust of Oregon, for their support. This event is also made possible by our members. Solar Oregon is a member-based nonprofit, so if you are interested in becoming a member, you can do so on our website, solaroregon.org, and you can also follow our social media and Eventbrite at Solar Oregon in order to hear about what great events we have coming up. So now, without further ado, I'm going to pass it over to Stracker Solar. Oh, one last housekeeping is throughout the presentation, if there are any questions that come up, feel free to put them in the Q&A button at the bottom of your screen. It looks like two little question text message bubbles and it says Q&A. We will be going through those questions at the end of the presentation. There's no need to wait until the end of the presentation to start putting in your questions. Feel free to put them in at any point. Now I'm going to turn it over to Jeff Sharpe, the founder of Stracker Solar. Thank you so much for being here, Jeff.
Thanks, Abby, and good afternoon, everybody. I'm Jeff Sharpe, founder and interim COO, sorry, of our Ashland, Oregon company, Stracker Solar. We incorporated in 2017, and we have been designing, testing, and improving this elevated dual axis tracking structure. For a number of years. We have about 66 installed and have been operating since as early as 2016. And the reasons we created Stracker was to provide a new class of distributed energy resource harvesters. They fit over parking lots, agricultural areas, recreational businesses, industrial, anything from residential all the way up to small utility solar. Strackers are module and inverter agnostic. You can use whatever normal systems you do. And by doing that, by tracking the sun, we see an extra 50 to 70% annual energy harvest than fixed systems. That's 70% better than a flat roof fixed system, and it's 50% better than a south facing optimally tilted system. This is the most efficient PV solar harvest platform available anywhere. And where a picture's worth 1,000 words, maybe a video's worth more than that. See if I can make this thing go. So that I don't know how well that showed on Zoom, but you can see that the Strackers are in this stow position at night. They stay flat, level to the ground. That's our safest wind position. And then every morning they tilt up and face the east to or north of east, depending on the season, to track the sun perfectly in each of the unique sun paths during the year to stay perpendicular and to maximize their solar harvest. So this slide's meant to show that something we use in some of our educational pieces, the summer versus the equinox versus the winter solstice. Unique path throughout the year. And by keeping our panels directly perpendicular to the sun, we avoid the refractive and the reflective losses and are able to capture the most of that. Results in a curve like this. We don't less of a duct curve for the distributed system in general. And again, this area between the standard fixed system and our tracking system is where we realize that 50 to 70% greater annual energy harvest. So why elevate? Well, a couple things that by staying perpendicular to the sun, we create the most efficient shading because we always have the full area of the array perpendicular to the sun. So the most efficient way to shade, great in times of climate warming. And especially we maintain the full use of the valuable land below. And of course, over parking lots, we make electricity instead of heating cars and heating the asphalt. All these are valuable, our value propositions then are the dual axis tracking and the elevation that maintains full use of the land below. Makes us perfect for agrivoltaics, no need for fencing. We can put inverters on the poles, or more commonly, we'll run lines back to a central inverter location, step up transformers where needed. We're set for utility SCADA hookups where desired, or distribution systems like the city of Ashland that owns its own utility. A lot of options with that. Combines, fire trucks, emergency vehicles, semis all fit under the 13'6" minimum ground clearance at full tilt. So this is the Stracker platform. We've been testing and working, refining this product for years now. We have 120-mile-per-hour wind certifications. The pole is perfect for horse seismic events. Excellent reliability and productivity histories. And we have a UL 3703 listing. And with that, we're eligible for Energy Trust incentives. Also, that's a comfort for a lot of people that want that the UL listings signature of safety and reliability. And because we use less PV modules for whatever energy is being produced, we have the lowest a lower greenhouse gas footprint than rooftop, carport, other fixed solar, and we get the highest PV efficiency. So that's less mining, less production, less demolition, and eventual needing to dispose of. And what our clients are telling us and really happy about is the powerful visual statement that they make about the commitment to solar power and technology. Ultimately, Stracker is a technology company, but we are now producing these. We have done EPC projects here in Southern Oregon and Northern California, but we are gearing our business towards becoming OEM, original equipment manufacturer, and providing this to other EPCs and PV installers. So here's a little bit of the specifications. Minimum 13.5-foot ground clearance at all time. We typically have come into 28 module configurations for our array. If you, the old 60 cell modules, 28 of those makes a smaller array that we call the S1A. When we get into the standard 72 cell modules, that's our model S1B. And recently, as the large format modules are becoming the standard and the most available, we are doing array sizes up to 26 by 30 foot, 26 foot by 30 foot, and with a power rating of a DC power rating of 16.4 kilowatts. Now, our AC-DC ratio, because we're always getting that maximum solar by being directly faced at the sun, we use an AC-DC ratio of 1.0. So you can count on producing as much AC as what these panels can. We're also using bifacial panels, have been using bifacial for years, and we're seeing another 7% kind of across the board mean increase in harvest due to the bifacial panels. Poles are typically 12-inch square. We can also do it round. Our drive mechanism up here, what we call the drive core, powered by two 14-inch slew drives, one about the axis of the pole for the azimuth and the other one on our tilt axis. Those are driven by 24-volt DC motors, and we have our whole control box, control system at the top of the pole in this drive core. What else can I tell you about that? All steel construction, all US steel. We're believing that we will qualify for the 10% domestic adder if you use the calculation method instead of the safe harbor tables. Here, we're opening up land use to a lot of places that otherwise wouldn't be able to put solar installations in, over parking lots, for example, areas between buildings and communities, places particularly directly on the distribution grid. Our increase in our production, as I said, and also installation time. The single pole construction means that we can handle hilly and rocky ground that otherwise might not be suitable, certainly for single axis. When we start getting into hilly terrains, we really dominate in terms of ability to open space. Foundation for these are typically about 30-inch diameter concrete piers, 6 to 8 feet deep, depending on soil conditions. We also have another technology that we're working with now of driving steel piles and eliminating the concrete part of this. Still in prototype stage for that. So we are working to improve this product, make it for all kinds of communities and tribes. One of our philosophies is to help bring community development to whatever, and economic development to whatever communities we go to by outsourcing portions of the steel construction, beams and pole welding, to shops in the local communities, and then bringing the drive core, the IP pieces to that, and helping make sure those get assembled properly in whatever community they're in. Obviously, we got a wide variety of markets, from megavoltaics to car dealerships, to recreational areas, to large microprocessor facilities. This is a model of an installation we're hoping will start in the next year up in the Portland area, where this microprocessor firm is asked and wanting to include their microprocessors in our control systems so that they can advertise how Stracker powers their facility and they help power the Strackers with the microprocessors. This is Evergreen Bank in Ashland, and beyond. You can see some Strackers here in TC Chevy. These, if you drive into Ashland through the south exit, they're nice to stop in and take a close look at these. As a company, we're community and tribe focused. Again, expanding the production, allowable, accessible production areas while maintaining open areas and parking spaces. No need for fencing. We have clients in the Idaho region that is a really big thing to wildlife, not inhibiting with fencing the normal migration areas or paths. And as I mentioned before, developing fabrication facilities, any pre-qualified welding shop can produce the bulky metal portions of this, keeping local dollars local and giving us both transient and lasting clean energy jobs. These are a couple of our current proposals that we have out there that we're hoping to do in the next couple of quarters. We have CREPA grants in for Coburg City's wastewater treatment plant and Indian Head Casino up in the Warm Springs tribe. We're expecting an RFP to come out pretty quickly for SOU here in Ashland that has gotten a couple $1 million in grants to spend on solar over their parking. And All Care up in Grants Pass is another one of the upcoming projects. So this slide just talks about that we're unlocking all kinds of markets with this, with the idea of just moving the DERs out onto the distribution grid. So we don't need to worry about transmission. We get to have more local power and local decision making in these things as we go. University campuses. You can hang EVCS stations off the side. We do lighting on the underside of a lot of the trackers as well. And with this, I'm going to open it up to one of our recent clients, Work Sharpe and Grant Lober. Take it away, Grant.
Awesome. Thank you, Jeff. So Workshop recently installed a set of Stracker systems, but backing up a little bit, we've been in Ashland and doing business for about 50 years. And we've always, worked hard to do a good job for our community, for our coworkers, for our vendors, for our customers. But in the last few years, we really have expanded our focus on environmental impact as well. And that can be a little bit tough as a small manufacturing company. We don't get to call a lot of the shots about how things are made or where they're made or how they're manufactured. But one of the things that we have been really proud to be a part of is this new installation with Stracker. And so we in 2008 installed a rooftop system. And so that's been in operation and since that time, and it's produced really well for us. But we wanted to see what we could do to do more. And we looked at Rooftop and we looked at the Stracker systems and found that, for our application, especially because we had this parking lot space, you can see kind of toward the right-hand side of the building, we wanted to be able to leverage that. And additionally, we wanted to take advantage of the visual aspect that these provide. Most people who had come to Workshop, and we host people all the time, whether they're vendors or customers or just people in the community, they get to see that they get to see the solar panels out in the parking lot now, and they have a visual appeal and kind of send a message about what we're doing, and also are inspiring them to think about what their impact could be. Whereas we had these solar, arrays on the top of the building for years, and nobody really knew they were up there, even though we had been generating about half of our electricity. And so we're at the point now where we're most months generating more than we need, which is awesome, because then we're able to turn that around and sell it back into the system and generate it locally. We've with the Inflation Reduction Act and some of the ITC credits, we've been able to project a payback of around 5 years on the system. And so it's not an insignificant investment, of course, to go into solar, but for a business that has been here for 50 years and plans to be here for a long time into the future, it really was for us a no-brainer. In addition, getting to work with a company who's literally a quarter mile away was fortuitous. They could have been 300 miles away and it still would have made a lot of sense for us. But that's been really neat to get to know the team as well as part of the local community in Ashland, and get to see the employment they're providing, as well as the training and the know-how to be able to do this kind of system. So that's been really fun to be a part of. And I'll say one of the really exciting aspects for me has been to see the groundswell of support from our team. We're in manufacturing, and so it was a little bit uncertain to me how coworkers would would feel about it. We're investing a lot of the business's capital in installing this system, and just what would they think? And we really just didn't know how that would go. And the overwhelming result has been really positive. People have actually talked about bringing their family by, and they've brought their families by on weekends or even during the work days and shown off the systems. And that for me is fun, that they can kind of go out there, and if you wait out there for a few minutes, you're going to get to hear this tiny whirl of these motors kind of spooling up and adjusting to track as the sun's going across the sky. And so it's just slowly moving. And that for me, that people get to see that it's not just throwing up some panels somewhere, it's doing it thoughtfully and doing it in a way that's encouraging others to do that. And so, we're, even as a small company with 120 or so coworkers, the fact that we've been able to do that and then spread the message has been really, really fun and really exciting for me. And so proud to be a part of the partnership. We expect actually to be able to start converting some of our HVAC systems toward electric from where they've been with a natural gas system, to gain efficiency and use some of that capacity, the electrical capacity that we've been generating. And so this has really spurred other opportunities to improve and make efficiency gains throughout our company. But one of the other aspects that's been really cool is the inspiration it's given to the people who are coming to our website. They're seeing it because we have a lot of B2B, a lot of or B2C, business to consumer web traffic. We're getting thousands of people a month that are coming to our website and are seeing what we've done here to promote this, and then they're getting inspired to that too. And so we've had people actually reach out to us and say, "Hey, what are these in your parking lot? We didn't even know this existed." And so that's been a fun part for us, to be a little bit of a testimonial of a different way to approach renewable energy, a different way to approach using some of that underutilized space. And so, yeah, proud to be a part of it. We're actually looking to see what else we could do in the future. And we just got maxed out by our building capacity to take electrical power, or we would have actually built a bigger system. This just was right up against the limit of 200 kilowatt hours that our existing transformers can handle. And so we kind of got limited by that factor. But there's a time in the future where we'll be back to the drawing board with Jeff, kind of scheming on, all right, what can we do next? And that's exciting for us to be a part of now and then into the future.
Yeah, thanks for that, Grant. Yeah, it's been wonderful and an honor to work with you guys in this.
Yeah, same here.
Okay, so I'm going to go back here and just go through a couple of these other projects that we've done recently. Here's a few of these. I mentioned the Evergreen Bank here on the bottom left-hand corner, and you can see the lights that they've set up at night to highlight the architecturals that they already have at that bank. This made them a fully net zero. They also have a small portion of roof that, for comparison of the systems. They've also opened up now a loan program for up to 20. I can't remember be careful with the number, but they do for residential and small business systems. They have a loan program available for solar in general, but also a carve out for Strackers. Here on the right again is TC Chevy. This is one of our early, I don't know, 2019 I think is when we started this. Pacific Power was slow in getting us service upgrade, but it's been up and running for several years now, and Alan DeBoer and team are very happy with this, and we expect that this will be moving into other car dealerships in the area. Up here on the top right is Franz Bakery. This is one of their distribution centers. This one happens to be in White City, and I wanted to show this one just because you can see that the semis, trucks fit under the Strackers and like to shade themselves in the day when they can. And then here on the top left, this is a pretty interesting, one of the funnest ones we had in this last year, besides Work Sharp, of course. And that is the City of Ashland Service Center, where we installed 75 kilowatt of Strackers along with 2 level 3 charge stations that will be bi-directional eventually. We have all the conduit in place for them. They're in the process of converting their fleet to electric. They already have quite a few electric cars, but they're planning in the future to also convert the truck fleet from fossil fuel to electric. And then at that time, these level 3 charge stations will be able to add battery capacity to help back up the electric department as it does now, but eventually also their internet, Ashland Fiber Network is located in that building. And with the battery system we put in here, we're able to ironically keep their emergency fuel pumps going, so ambulances and fire trucks can stay on the road. But eventually, with the bidirectional level 3 charge stations, they'll have a lot more capacity. We also, the battery system that we put out front, you can't really see well here, but it was specifically for that purpose. And with that, I guess we can open it up to discussions and questions, and maybe hit Grant first if you guys have anything there while he's
Absolutely. I'll
still.
go through some of the questions that have come in already.
Okay.
One of them is from Michael, that 20 years ago, the prevalent wisdom was that the cost of tracking systems combined with the maintenance and failure risks was not worth it compared to just adding more fixed panels to a project to reach the desired yearly production. Can you talk about the costs and maintenance now?
Yep, and that's a stigma that we are up against, because in the 80s, 90s, particularly the race to the bottom for utility solar, you had single axis, dual axis, and fixed all kind of vying for this burgeoning market. And dual axis was considerably more expensive in a lot of respects. So in the race down, a lot of corners were cut, and a lot of trackers failed, and that stigma carries on today. It's only in the last 7, 8 years that our construction tolerances, our material strengths, and our control systems have gotten to a point where we can comfortably do what we're doing now, that we have the robustness and the reliability to be up in the air. In terms of price, I'm actually in San Diego at this moment. We've been comparing carport systems for San Diego State University, and we're showing about a 20% better return on investment than fixed carports. Car canopies is what they're doing. So whereas it's been cost per kilowatt has sort of been the industry standard for how much do these things take to put in, we're really working to emphasize, really, we're interested in the cost per kilowatt hour. It's what we produce. So a 30% greater cost for our tracking system, coupled with the 60% greater harvest, ends up really still putting us out front. And our history of reliability and robustness, it kind of speaks for itself, but will continue to as we improve the product.
Awesome. And then related to that, we also, just because you ended up talking about the price per watt price, could you expand a little bit more on the approximate cost per watt of tracker versus of a traditional mounted solar and inverter combo?
Oh, I don't have.
I know every time I get that question, I'm like, it depends. So
Yeah,
no
it is.
judgment here if you don't have that in front of you.
Yeah, very site dependent, but I can tell you that, like Grant spoke to, with tax credits, we've been coming out in that 5 to 7 year simple payback period, and compared to carports and canopies, I'm seeing that we're beating by 20% in terms of standard rooftops. We have also, when we've gone head to head, have prevailed in that.
Absolutely. I'm gonna answer one of the questions or just respond to some of the comments. Some people are putting in some comments about how we at Solar Oregon could improve and make these webinars a bit more accessible. Anything like that, please feel free to reach out to us at info@Solar Oregon. We're not going to take time today to go through all those suggestions, but I am seeing them and making note of them, and emailing us there at info@solaroregon.org is a great way for us to see those ideas as well. And then the next question is, someone asked how Stracker would contrast or compare with the all earth trackers out of Vermont.
Yeah. Well, interestingly, All Earth was, we were installing those in 2015 under California's Proposition 39 program down at Grenada Elementary, and we realized that we're fencing off yet another playing field so that we can put in these 3 Strackers. And that's actually birthed the idea of, oh, if we put these on top of a pole, we won't have to fence these fields. And that's where the original Stracker concept came from. All Earth has done a really good job of packaging almost a do-it-yourself system where it comes in a couple of crates and you can fairly efficiently and economically either use an auger foundation or a regular concrete foundation to put this thing together. I want to be careful about down talking them, but I can say that we really ran into issues when we tried to get wind ratings and tried to get structural engineering to show that they could handle 90-mile-an-hour winds in California. There are some pieces and plastic bushings that are just don't cut the mustard for what we're trying to do here with robustness. Also, they are hydraulically driven single piston actuator for their elevation, for their tilt, and then a hydraulic gear motor system. And we continue to have problems with hydraulic tanks and hoses breaking in that system. They have done a great job of marketing. They have a lot of them out there. We did validate that their dual axis tracking is producing more than they're claiming. And these numbers that we're using here of the 50 to 70% are holding up. So I think they have their place. They're generally more of a residential type system, low to the ground. The value propositions that I spoke of are the greater efficiency of dual axis tracking. They are getting that. And so similar in that way. They're smaller. They really don't have the wind ratings, can't handle the being elevated, and are sort of a different class and nothing in the size range of what we're talking about, 15 and 16 kilowatt systems.
Absolutely. Next question is, so Anonymous asks, so Tracker is geometry based, not output based, so it is not optimal during partially obscured sky and does not take into account ground reflectance, correct?
Well, I can tell you the control system for the Tracker is an algorithm-based control system. Every morning, its GPS tells it that it's got the right time and the right location, and the algorithm then knows where the sun's going to be every minute of the day. Similarly, through the Hall sensors in its motors, it knows directly where it's pointing. So there are sensing systems that will during different shade, particularly in single axis systems, they will have a sensor that helps optimize where the greatest light is. Our experience, my experience over the years is 99% of the time facing directly towards the sun is where you're going to get as much as you can get anytime from sunrise and throughout the day. By using bifacial panels, we also have any direct reflection off the back, and particularly the diffuse reflection coming off the air is optimized as well. So I would argue that just always staying pointed towards the sun, regardless of the cloud cover, and being able to catch the reflection from the back is as good as it gets.
Definitely the more sun we can capture, the better. We don't want to let any of that potential power go to waste.
Right.
The next question is for Grant, and that is, what was the process for working with Stracker on design and construction?
Yeah, so it really begins with understanding our building capacity, what we can handle with our transformers, because that would determine, how much we were able to add without having to undergo a significant electrical renovation, which is to be determined. We may end up going further in the future because that has a further return, but of course that adds an extra level of complexity and an extra level permitting and a cost. And so really sizing it for our application, like what can we handle without having to do significant changes? That's one factor. And then the second is really the site selection and looking at the opportunity spaces. And so if you wouldn't mind even scrolling back up to our slide there, Jeff, with the panels, it's difficult to see from here, but on the right-hand side, what we used and what Jeff and the team selected were basically already pre-existing landscaping pods in the middle of a parking lot. So in any parking lot, whether it's a Fred Meyer or it's some other location, you've got this kind of unused space when a lot of the times it's used for drainage, you know, because a parking lot needs to drain all that rainwater off of surfaces. And so they use that, and there's some, and so some of that can be utilized, and it's basically totally unused space for anything else. So from there, we determined, okay, we can put in 6 of these, and each, you know, and that matched up with the sweet spot of not having to add electrical capacity. All right, so then it's into, all right, what's our building capable of, and what wiring and cabling do we need? And then also, we've got a manufacturing operation. We're bringing in goods from all over the world and shipping them out all over the world on a daily basis. And this was right in the path of our loading docks. And so we worked with Jeff and the team to figure out, okay, we're going to put these up, and we know that the semis will be able to drive around underneath of them because they're 20 feet up, and the semis don't go any taller than that. But we needed to make sure that we could continue to ship product in an uninterrupted way. So Jeff and the team were really helpful to project manage our way through that. So getting the permits from the city and doing all of that, notification of the neighborhood and all of those steps, at the same time building out a plan to be able to put these in without having major disruption. From there, you know, one of the clever things they did was really that the technology's come a long way with boring capabilities. And so they were able to bore in all of the wiring underneath the parking lot so that there's very, well, I would say no disruption to the parking lot surface. So we're not having to rip up asphalt. We're not having to repave things. That made it really easy and seamless for the work to go on to put in these panels while we were literally having trucks come and go to bring us goods. And we have a small factory here, so we're building them up. And our 40 or 50 people in production didn't even know what was going on outside. It didn't matter. And so that was really a cool thing that we were able to basically just have people park on the other side of the building for, you know, maybe a few weeks to a month while those went in. So first you've got the foundations, and like Jeff said, one of the reasons we went with Stracker versus some of the other systems is there really isn't anybody else who I would consider commercial grade. Like there's some really good residential systems, and they're probably cheaper, and they'll work in some applications for sure, but we wanted something. You know, we're parking people's cars who work here underneath of it, not just a random field. And so we can't have these things tipping over, falling over, that sort of thing. And the UL listing, the rating, that was really, the wind ratings were really important to us to be able to know that that was going to be, you know, safe for people to be out there in their cars and their parking lots, out in the parking lot. So from there, they're digging deep holes to put these foundations in, build up that structure, and then from there, bringing in the parts and pieces. And so the Stracker team handled, you know, we had to coordinate a little bit with the city and a little bit with the electricians just to have the doors open at the right time and coordinate all that. But in a matter of a few weeks, everything was wired into our existing inverters to be able to basically add to the existing system. And that went seamless. We flipped it on, and the next day we could see on the website, you know, the sun come up, and we could see production start and this ramp up to the top. And then you could see this little, to the last question, you could see a little dip there in the middle of the day when a cloud rolled by. But because it was pointing right at the sun, it almost immediately jumped right back up to max capacity and just kept there until, you know, until the day, you know, changes. And of course, as the sun goes past the hills, it drops off again. So for us, that whole process from start to finish was on the order of 2 months, and probably half of that was waiting for, you know, local municipalities, the city of Ashland and such to do the permitting process and get through all of those hoops. It went in relatively quickly, relatively seamlessly, and we were able to have it up and running within 3 months of getting a quote to fully operational, which I mean, for a capital project, that's incredible. That part was really fun to witness because, you know, in my mind, I thought, yeah, sure, Jeff, 2 months, right, it'll be 4. And, you know, you just kind of assume that these things are going to take longer, or they're going to be cost overruns, but sticking to the budget, sticking to the timeline, with the exception of waiting for, you know, the city to get through their job, and that's fine. You know, that happens. That's an acceptable, you know, thing to have when an inspector can't get out. But to have it fully signed off within that short time frame and operational, really made it an easy thing for me to then talk to other people about. There's, you know, we don't have any other connection other than this project. And for me, it's helpful to talk about it when it goes that way. It's easy to be a testimonial when the project goes that smoothly. So I hope that's not too much information, but for us, it was it went really, really cleanly. And that's what I've heard from others in the community who've also had similar installations, whether it's from Evergreen or TNC, Town or Country Chevy. It's gone about the same. And so that's really for us, we pride ourselves in customer service. And that to me is important when you're going to invest in this kind of a system, to know that there's the company behind it who's going to stand behind their work and do what they said they're going to do.
Great. Thank you for that, Grant. I'll add a couple other short pieces. One is they did have these parking lot islands, so we were able to directional bore underneath the parking to those points. If they hadn't had those, and we have a lot of other installations where that's the case, including TC Chevy, we'll typically auger our foundation holes, and they can be where two parking spaces come together, where the head and the bottom of another one is, and you can go ahead and put a Stracker pedestal in there, reduce the one of those to a compact parking space. So we're able to install in almost any parking situation without losing parking spaces. Another thing we did with WorkSharp is they have a pretty nice LED lighting system in place, so they didn't need lights on the Strackers, and we ended up moving a couple of these Strackers, making them about a foot taller to be able to clear those lights below. And the third piece that I mentioned about this is in the city of Ashland has their own distribution grid. They're supplied, their BPA purchasers, and BPA at this point has a 200 kW solar max per transformer. So because they had a fairly large rooftop system to start with, but the 75 kW of Stracker kept us under that 200 kilowatt, and so that avoided needing to upgrade the service and upgrade the transformer. Just a couple other notes on that.
Awesome. Next question is, what powers the 24V DC drive? Is there a battery on the system?
Yeah, that is an option. We have put batteries on top before for when power goes out, to make sure we get to stow comfortably. Also, putting UPS systems on the control system is something that we've done and are available to do. Typically, we'll run a single phase, either a 208 dual phase or a single phase 120 system out to the tracker, so you have that power available if you want to put Christmas lights around them or whatever else. And we have a power supply that takes that single phase and converts it down to the DC control and 24 volt voltage. So I guess the answer to that is we typically run a single phase control circuit out to the Strackers, and if we have lights, we'll also run another single phase circuit. It could be 277 single or 208 to power the lights as well.
Awesome. Next question is, you said that your system was panel brand agnostic, but the size and power rating of residential panels keeps growing all the time. Can you speak to if that impacts or makes a difference?
Yeah, well, one of our early models was the model S1A that used 60 cell size panels, the smaller residential panels, and gave us about a 10 kilowatt unit that looked beautiful, worked well. But we realized we could get a little bit more by going to the 72 cell mods, the bigger commercial type modules, and that became our model S1B. What we have installed is it's been our primary model. The S1B is out all over the place, and that's about an 11.4, 11.2 kW. We were using 450 watt modules bifacial, a variety of suppliers. They were pretty standard in their sizing. And in the last, I don't know, half year, the large format modules are what's really available to us in bifacial now, and at the cheapest prices. So we're now developed the model S1B2 that again will be 30 feet wide, 26 feet tall, and so we can handle 28 of the typical large format modules, and that's getting us up to 16.4 kW size units. So in terms of being agnostic, we don't care what those modules are, but depending on their size, the output of your unit is going to be 28 of those. Could be a S1A, could be an S1B. More likely, we see for our bigger commercial and in small utility scale projects, it's going to be the S1B2 using the most readily available large format modules.
Very cool. It's great that there's so much variety in what modules you can use and fit. You can really customize it. The next question is, what would you say Stracker Solar's niche is?
Oh, that's an interesting one. It seems like we've got quite a few. Feels like we're in a blue ocean market right now. So parking lots are one that comes immediately to mind, just because we've got so many acres of parking lots across the country that we could be turning into power plants. But agrivoltaics as well. Um, it's a good companion crop. We're actually doing a project coming up here with OSU. And one of the interesting things that they are asking for is for lettuce production, that there are times in the winter where the warmth of the sun is going to be more valuable than the electricity produced. So one of our algorithms is going to allow the Stracker to actually be put parallel to the sun to minimize the shade to almost nothing, so that you get that sunlight, that warmth on the ground during the times of year where it's more cost effective for the farm. So back to niche, anywhere that we open up spaces between buildings, over recreational areas, over farms, over parking lots, that where you don't want a fence, where the land has any value at all, and able to complement with this companion crop of producing power.
Speaking of agrivoltaics, can you talk a little bit more about that? One of our attendees heard about a project for a co-op farm in Willamette Valley that they're curious about and would love to learn more about agrivoltaics.
Yeah, well, it's agrivoltaics. It's just, does this work as a companion crop? And we're believing it will. Interconnect has been an interesting thing dealing with the investor-owned utilities. But if you can get a decent interconnect and you've got the power can be accepted. Again, we have some options of minimizing shade when you want it, but most of the time we think it's going to help retain moisture in the soil below. And for the majority of crops and grazed lands, we are tall enough to handle typical combines and the full farming operations. So I think it's a farm's best solar friend.
I know I've gotten to go out to OSU's solar harvest facility before, and it's really great seeing some of the agrivoltaic plants in action. If you're interested in agrivoltaics, there's some great webinars on our YouTube channels and around the internet on how agrivoltaics work. So definitely keep an eye out for those. Someone else has asked how Stracker might contrast with Beam, which includes battery and car chargers with a portable unit and no permit or construction fees.
I'm sorry, is Beam the EV charge station group? I I,
Um,
I
I
think
would
that it,
assume so,
yeah,
but
I think I'm remembering that these guys are out of San Diego. That basically it is like a platform that you can drive your car up on and plug in, and then they have a fixed roof over the top of that. So the amount of energy actually produced by those 9 panels or 12 panels, whatever the residential panels there, is not, is not going to not going to be able to charge any cars in the first place. And again, I mean, it's nice, a good concept in a lot of respects in terms of its actual power production and economics. It seems a little bit more like a novelty, like the solar flower and some others.
speaking of car charging, is it possible to put car charging modules under a Stracker system?
Yeah, so we have at 5 foot, at the 5 foot level on the pole, about, if you can see my cursor down here, we'll often, like if you go by any of our car dealership installations, we'll put a 3-inch nipple and cap there that allows bringing the EV charge station cables, the 480 volt if you're talking level 3, whatever it might be. We can hang it on the side of the pole there, a 12-inch square pole, or we can feed to a freestanding island of the charge stations. In terms of the power produced by the Stracker itself, that would be a trickle charge in general. So it serves mostly as a platform for bringing a higher power source out to the parking area, if that makes sense.
Definitely does. Um, Next question, and I think we'll have time for probably 2 more questions before we have to get going. So if we don't get to your question, I'm really sorry. Jeff's email is at the bottom of the screen. So if you have any other questions for him, I'm sure he'd welcome hearing from people. And again, you can email us at Solar Oregon at info@solaroregon.org. But second last question is, in North temperate climates, shelter from rain and snow are higher priority than intermittent shade, leading to carports having an advantage over trackers. Do you have any thoughts on that?
Um, well, right at this point, we do keep a half-inch spacing, thermal spacing for between all of our modules without a rain shield below. You can see here we do actually have a 3-inch gap down the middle because we have a hook for lifting the array off if you ever need to replace anything on that, and for lifting the array to the top of the pole. It's a temporary hook that comes off and a rain hood goes in there. In terms of protecting the vehicles or below, at this point, we are not offering that. It is something that could be done with some sort of metal underlayment and curbs down at the bottom, but that's not something we're offering. Interestingly, I've seen a lot of carports, and the majority of them, in my experience, do have those open gaps. And I guess I don't know that that is what the majority of them is, but I know a lot of them are open. At this point, we are not offering that.
Different things for different situations. Not everything's going to be a perfect fit always. However, as our last comment says, it seems like anywhere like San Diego or California with time of day utility kilowatt hour pricing, your system would really be a winner.
Agreed. Thank you.
Well, thank you everyone for your time today. Thank you, Jeff and Grant, for being here. We really appreciate it. Thank you to everyone for all your insightful questions. Again, feel free to email jeff@strackersolar.com if you have any other questions that we didn't get a chance to answer today. And you can also email us here at Solar Oregon at info@solaroregon.org. Thank you, everyone, and I hope you have a great day.
And thanks, Solar Oregon. Thanks, everybody. Bye-bye.
Thank you.